Most of this assignment and most of your assignments this semester, you're not going to be editing text blocks, but more likely you're going to be adding your own Python code or editing a partially completed block of Python code. If you want to add your own little block of Python code, you can hit this button over here. And that's going to insert a block of Python code just below the cell that was active when you clicked insert. But I don't need this here. But in general, if you want to add a new block of Python code, you just hit that plus code button. And you can see the Python code blocks appear in gray, and there's a little play button next to them. So there are two things that you probably are going to want to do with Python code, and that's going to be run it, what we call execute it, and edit it and rerun it. So if you want to run the code, you just hit the play button over here, or you can go in through the right mouse menu. You can run the focused cell over here. So this is what I got from the right mouse. Use the keyboard shortcut. Sorry, that's below here. The Command Control Enter sequence over here. Sorry. So yeah, if I want to run this, I just hit the play button over here. This should take really quick to run. So I can run it by clicking the play button. And this is calculating how many seconds are there in a day. So this seconds in a day, we define this object. So this is where we are going to store this calculation. So this is going to calculate 24 times 60 times 60 again. And that gives us 86,400. So there's two lines in this. This first line, let me just delete the seconds in a day. If I just run this, I don't see any output here, right? But this did do the calculation. I just don't see it. So if you want to see the output, then what you actually need to type is what is the name of the object where you just saved this output. So this line of code is actually doing two things. The first line is calculating this value, but not displaying it. And the second line here is going to display the output of the calculation to the screen. And I can see that over here. And otherwise, we just edit these blocks like we would other ones. I just double click on it, and then I can type stuff over here. And what I get is if I type stuff that doesn't make any sense, we'll get error messages over here. And we might have to debug that piece of code based on the error message that we get on the bottom. So these blocks, we can't just type random text as we want because things are going to be read very, very literally as Python code. But I can edit it back and then run it over here. Okay, so yeah, if we want to run the code, then again, you can either hit the plus button, the play button, or you can use the keyboard shortcut of Command or Control plus the Enter button. So on a Mac, it's the Command button, the Apple key that I would use. So I can come over here and just do Command and Return, and it runs the code. So if you prefer using your keyboard, that's a nice way. If you want to use your mouse, then you can just click on the play button. And so notice here, this code took seconds in a day and multiplies it by 7, the 7 days in a week, to calculate how many seconds are there in a week. And one thing to note is that this calculation, seconds in a day, we calculated in the previous block of code, and that's been saved into this object. So now anytime I type seconds in a day, Python is going to read that as what value has been assigned to seconds in a day, which is this. So the output that I get from the block of code that I just ran previously can be input into the next block of code. And this is just something to be aware of, that sometimes that's really nice that I define something over here and it gets read in down here. And sometimes that might be problematic depending on what you're doing. Okay, so each of these two blocks of Python code that we had, they were doing just one single calculation. but certainly blocks of code, these can involve doing several operations at once, or can, you can define functions and create graphics and do all sorts of fancy stuff. And so what's really nice about the Python community is that there are a lot of people out there programming in Python who have set up little scripts that they've saved to libraries that then other users can use and import and use those scripts. So one of the most useful libraries in Python is what's called NumPy. And this has all sorts of things in it, like different function types and so on. So if you want to use any functions from the NumPy library, you need to import it into your block of code. So my block of code begins with import NumPy. And now this means any scripts that exist in NumPy, I could use in my code. I just need to indicate that the function that I'm using comes from that library. So we're going to be working with arrays in Python. So arrays are, matrices. A matrix is a two-dimensional array. A vector is a one-dimensional array. So NumPy is really nice because it gives us a nice array environment to work and do kind of arithmetic with matrices. So I want to define a matrix A. And this matrix is going to have 4 different rows. So the first thing I do is I say, where am I going to save this matrix to? So I'm going to save it to this object that I call A. And how do I assign something to A? I use the equal sign here. So whatever happens on the right side of this equal sign, that's going to be stored as A. So I want to set up an array, and that array is in the NumPy library. So I start with saying, okay, go into the NumPy library, dot. Use the array function in the NumPy library. So this is going to, whatever input I enter into the array, it's going to format it as a matrix. So then I type left parenthesis. And then inside of my parentheses, right, you can see there's an ending parenthesis over here. I'm going to enter my array. So I have 2 brackets over here, and I have 2 brackets over here. So first I have a left bracket. So this means, okay, now your matrix has begun. And inside of these brackets is my first row. So my first row consists of 1, then 4, then 3, then 1, and then 18. And I've separated my columns with commas. So when we were using LaTeX, we used the ampersand symbol to denote different columns. When I'm working in Python, here just a comma is going to denote we've ended that column and we've gone to the next column. And once the entire row is entered, I end it with another closing right square bracket. And that indicates this is my first row. And then I have a comma to indicate, okay, now we're going to move on to the next row. So here is row number 2. Here is row number 3. And here is row number 4. And so you want to see what this looks like. I'm going to kind of get rid of that. So if I just run this block of code, it doesn't seem like anything happened, although something did happen. So if we actually want to see that this matrix was assigned to A, we need to show this output somehow. So one way that I could have the output is just type A over here. And now when I run this, it tells us, okay, A is this array where the first row was this, the second row was this, third row was this, and the fourth row was this. We have 4 rows, and here we have 5 columns. So this is a 4x5 matrix. And one other thing to note is in instead of typing 1, I typed 1 with a decimal point. And the reason why I have all of these decimal points is because I want the entries of this matrix to be read as like decimals as opposed to integers. So when we do arithmetic, I want to see answers expanded out, as their decimals, as opposed to saving things as integers. So that's why I have the decimal points after each of these numbers. I want each of these entries to be read as a floating decimal as opposed to an integer. So one way to see the output is to just type the name of the object. We'll talk next about print commands. So this is a built-in function in Python, the print function, which allows us to print things to the screen. So I can print any text that I want to enter in between double quotes. So this first -n is going to be a new line. So it's going to be a line break. And that's why I have a blank line over here. Then I have a is equal to, and then next comes the matrix out. And whatever I type in double quotes over here is going to appear. And I can change my line break around inside here accordingly as well. So now the line break was insert after the equal sign. So we just created our first matrix, and now we printed that output to the screen. And so here's just a little note about why I used decimal points. So the output from Python block is not going to appear as nice as it does in LaTeX. So that's why it's useful to take this output from Python and be able to format it in a nicer so that you could kind of submit our report. So Python doesn't necessarily format things nicely. Okay, yeah, so printing output to the screen, or printing anything to the screen. We saw that there are different ways that you could do it. So up top in this block of code, I don't need to have a print command over here. I could just type A if I want to see what A is. So sometimes this is nice if you just want to quickly make sure that your code is working correctly. But if you want to actually enter some formatted text of yourself to explain the output, that's where the print command is useful. So typing A in this block of code, or typing print A, pretty much has the same result. But the advantage of the print command, again, is that we could type text, we can enter line breaks and so on. So we can make our code look nice. And so here's an example of, this was a total purposeful mistake over here. I got an error because anytime you want to kind of move from type literally what I'm typing between these double quotes, and then you want to change over to print the output that was stored in a certain variable to the screen, I want to denote that I'm ending my typing out text string, and now we're going to begin printing the values that were assigned to this object A out to the screen. I had to put a comment in between here. So this says here's some text, double line break, end typing in text, and now show me what was stored in A. That comes next. Yeah, so again, the difference is this will just print A, whereas this will print some text and A. So here we can see, if you want to describe what A is, you can say here is the augmented matrix. Okay, so far we've been kind of writing code that does more or less like one operation, and talked about how we can, different ways we can print that out to the screen. When you're doing more involved Python code that's going to have multiple steps in the same block of code, it's nice to add comments. Sometimes this helps yourself when you're reading your own code a month later, you might forget how your own code works. And it certainly helps a lot when you're sharing code with other people. So comments in Python code begin with an ampersand here. Excuse me, begin with a pound symbol here, the hashtag over here. So when I run this block of code, this is going to be ignored. Anything that appears with an hashtag before it gets ignored. Anything that appears before a hashtag or without a hashtag is read as actual Python code. So let me remove this. Without the pound symbol here, this is being read as Python code. So you can see is a special word, in is a specially defined word in Python. So it's going to try and read this first line as like, do something in Python. So when I run this, I get an error because it's trying to interpret this in terms of Python. Whereas if I put this pound symbol before it, this is just going to appear on the screen, but it's not going to be read into the code. So now when I hit play, I didn't get an error. So here you can just kind of, it's a nice way to describe how different parts of the code work. So in the previous block, we imported NumPy. And then when we wanted to create an array, we typed NumPy array. What's a pretty common convention is to shorthand NumPy as NP. So when I take import NumPy as NP, this just means instead of typing NumPy over here to create an array, I can do that with less typing. I now just type NP. So this saves yourself a couple of characters. It might seem like, what's the point? But if you're using this a lot, many times over, saving yourself a couple of characters can be useful. So that just changes how we called in this array. But what this code is doing is we define this matrix A. And then down here, we defined the first column vector of this array I called A1. And now if I want to print that output to the screen, we can see that below. If I want to add another line break, I can do that